Dear students, today we will learn how to represent numeric values in computer. In the last module, we have learned that how to store textual information on computer. So there were some issues if we take the same approach of textual information storage to store numeric values in the computer. Let's have an example. If we want to store 12, so we have learned that 1 would be treated as one symbol and 2 would be treated as another symbol. So we would need 8 bits to store 1 from 12 and another bit, a whole byte to store 2. So this means we would need 2 bytes or 16 bits to store only the digit 12. However, we will shortly learn that with the usage of 16 bits, we can actually store 65,535 numeric values. So that is really a surprising fact. So if we use the only textual information processing approach, storage approach here, we would only be able to store 2 bytes. To store 2 digits, we would only taking 2 bytes to store 2 digits. So this means that we could store 99 in the 16 bits. That's it. So the maximum number which can be represented in 2 digits is 99, and those 99 could be stored or annotated in the computer in the form of 16 bits. However, we will learn that with 16 bits we can store such a huge number. Let's see. So for this we use the binary notation, and let's discuss as an example of representing numeric values using binary notation. So for example, we have 3 bits. So let's see, we have 3 bits: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So these are all possible combinations which can be formed with the 3 bits. So 1, 2, 3, 4, 5, 6, 7, 8. And if we say that this will represent the digit 0, this will represent the digit 1, this will 2, this will 3, 4, 5, 6, and 7. So this means with only 3 bits we are able to store numbers from 0 to 7. So we can store or represent 8 numbers, and the maximum number which we can represent with 3 bits is 7. So if we take another example of 2 bits, we can see with 2 bits we can write 0, 0, 0, 1, 1, 0, and 1, 1. So this would be 0, 1, 2, and 3. So with 2 bits we can represent 4 numbers ranging from 0 to 3. So this means we can say that whatever the number of bits we have, so for example if we have 2 bits, we can represent 2 raised to power 2, which means 4 numbers, and the number would vary from 0 to 3, which means 4 minus 1. So the maximum number can be represented 3 starting from 0. And similarly here 2 raised to power 3, which is 8. So 8 numbers can be represented. Minus 1 would mean from 0 to 7. So if we count numbers from 0 to 7, those would be 8 numbers. So this means we are getting such a formula that we need to write number of bits as a power of 2. Then we can see that how many actual numbers we can represent, and we need to then again put a minus 1 at the end to have the maximum number which can be represented. Let's see whether it holds for 4 bits or not. So if we have the same 3 bits 0, 0, 0, 0, 0, 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1, and another 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, and 1 1 1. So if I add 0 with the first set and 1 with the second set, so this would be 0 1 2 3 4 5 6 7, and this would be 8 9 10 11 12 13 7 8 9 10 11 12, and then we also need 1 0, and then 1 1 1. So it would be 14 and it would be 15. So you can see that with 4 digits we can store 2 raised to power 4 numbers, which are 16, and the maximum number which can be represented is 15, which is 16 minus 1. So if we generalize this concept, if we have 16 bits as we were discussing in the first slide, this means we will have 2 raised to power 16 combinations, and 2 raised to power 16 combination, if you perform on your calculator, you will see 65,536. These are the numbers which we can represent, and starting from 0 we can represent 0 to 65,535. So by representing only in textual form, we were able to represent maximum number 99, but with the binary notation we are able to represent with 16 bits the maximum number 65,535, and most probably you have learned this concept. So in numeric, how the numeric values are stored, so we normally take 2's complement for storing the values, which we will be discussing in the next modules, and then for storing the fractions we use floating point notation to store, but the basis of the binary notation is the one which we have learned today. So now if we summarize today's module, that we have seen the issues in Unicode and ASCII code to represent for numeric values, but as far as the textual values are concerned, those are fine to represent using ASCII and Unicode, but in binary notation you can actually store the numeric values very efficiently.